Hi everyone. Today we're going to be discussing a string related problem. It's a very simple problem, but it's good to know how to deal with it either for your interviews or just for the sake of learning how to deal with strings on a very basic level. So what is the problem? So here's the definition of the problem. Implement an algorithm to determine if a string has all unique characters. What if you cannot use any additional data structures? So first we're going to go through the first solution. We're going to discuss it a little bit, and later on we're going to talk about the bonus question. Here we go. Now we create our file, uniquestring.go. As before, vimgo is going to provide us with a basic vim file. So we're going to be creating our function has unique chars. It's going to receive a string as input, and it's going to return a boolean value. Here we go, the parentheses. So if you get this question during an interview, the first thing you want to ask the interviewer is, what kind of characters you're going to be dealing with? Ask if you can assume that these are going to be only ASCII characters. Or maybe they want you to deal with Unicode characters. This is going to first show that you understand how strings are represented in the system. And it might also give you some leverage during implementation. So in our case, we're going to be assuming that these are all ASCII characters. So before we actually go for the implementation, let me explain a little bit of what is the thought process here and how we're going to come up to a solution. There are a few ways to deal with this, and the most intuitive one is, for example, let's say you have a piece of paper and you're solving this problem in a piece of paper. What probably you would do is you would look at the first character, you would write it down, and you put a 1 beside it, and then you would go to the next character, and if it's a different character you would write it down again and you put 1 there, and you would be going this way until you have a character that already appeared before, and you're just gonna go and update and erase it 1 and put a 2 or 3 or how many times that character appears. And that's how you would check the number of appearances of a character in the string. The problem with that paper solution in the case of actually writing the algorithm in the computer, and here I'm assuming that you cannot use the hash map implemented in the language, and that you're not going to spend time to implement the hash map just to solve this very simple problem, is that you're going to have problems to store which character has each value only using arrays. And even if you're able to do that, for example, using a linked list or using multiple arrays to store those values, what would happen is you would have to go across the whole array to find which character you want to update right now. And that is not efficient. So what we do here is we're going to create an array of ints that holds the size of all ASCII characters. So in this way, what you can do is when you get a character, you can get its ASCII code, its ASCII number, the number of that character in the ASCII table, and you can just update that position in our chars string, our chars array. We could call this a char map, for example. It could be any name you want. So this is the reason why we're creating this array. So the next thing now you're going to have to do is going again on our paper solution. Now that we actually have a place to store those values and to know where they are, first thing we're going to do is we're going to loop through our string. So I'm gonna have here index and the character, and these are gonna come by arranging on the string. Okay, so the next thing we want to do is we want to get the ASCII code for that character. And an important thing here is when you're using Go and you loop through a string, it's going to return you not a string with one character, it's going to return you a rune. If you want to know more about what a rune is and learn more about strings in the Go language, check the links on the description. So, to get the ASCII code, what I'm going to do is the code, and the only thing I have to do is to turn my char into an int. You can automatically convert between runes and ints. Done that, next thing I'm gonna do is I'm gonna do chars code, and you increase 1 in that position. So you could go across everything and then just check the whole chars array later on, but we can just check right now. So is chars code if chars code is bigger than 1, then we can just return false right now, because we know that this character already appeared more than once, and we don't have really to check the other ones, because it means that for the question we were asked, is this string made of all unique characters? Now you know that no. So you can just return false right away. So this is pretty much it. And if you never return false, it means that the string contains only unique characters, and you can return true in the end. We can actually give this a try. For example, let's try with this string, for example. So we're just gonna print the result right away. So let's try for vim_go. So go run. You can see here that when I saved, it complains that index is declared but not never used. So as we've seen before, we're just gonna replace this with the underscore character. That means that we're not going to be using this value, we can just ignore it. So now let's try to run this. Go run, and unique characters, unique string.go. One of the interesting things about the Go compiler is that it lets you to run without actually having to create a binary file. So here we go. You can see that it's true. It returns true to us, and we know that's correct because if you check the string, you know that there are no repeated characters. Now let's try testing. We have 2 t's in the string, so it should return false to us. Go run unique string, it returned false now. Cool. So there's actually another improvement we could do in our solution, actually there are a few ones, but the first one, the most simple one is, we know we have a space of 256 characters. That means that if the length of our string is bigger than 256, we're gonna have for sure a repeated character, and we can just return false right away without actually having to go through the job of running through all of the characters here. Okay, cool. There's a different solution that I'm not gonna go through, which is you could actually save space. Instead of using an array of 256 characters, what you could do is you could use a binary vector. Let's look at a number and think of it in its binary form. A binary number is composed of zeros and ones, which you could think of as true and false values. So in this case, if you have a number with a maximum size of 256 binary digits, you could use that as your array, or your kind of array, to save those values, and I'll leave that as an exercise to you. But here we actually using extra space to save the values that we have. So, but remember that the question said, what if you cannot use additional data structures? If you cannot use this array to actually save those values. So we're gonna have our first for loop, then we're gonna have our index that this time we're gonna actually use. We're gonna have our character, which I'm gonna call char1 because I'm gonna have a second one. And we're gonna range to the string. And here we're gonna have our second for loop. We're not gonna be using this index. We're gonna have our char2. And here we're gonna have a range string. And the difference is here we're gonna be going from the index plus 1 until the end. Then what we do is, if char1 equals to char2, then return false. If not, in the end we should return true. And this looks good. So one question that you should probably be wondering, and this might cause problems in different languages, but if you look here, we're actually ranging through the whole string until the very last character. We're not really going through, we're not really stopping on the one before last. And strictly we should, because especially in different languages, what would happen here is we would go and try to compare the last character to the one after the last one. And depending on the language, you could have errors that you cannot really know what it is, because you might be accessing memory outside of the scope of that index. You would get an error. There are many other possibilities here, but in the case of Go, when I try to do index plus 1 until the end of the string, and this index plus 1 is already bigger than the actual string, it's just not going to return anything. So we're not going to really have a chart to compare. It's going to skip this step completely. It's not going to enter the for loop, and it's going to go straight out. So we're safe in the case of Go, but you should be aware that if you're implementing this in a different language, you probably want to make sure that you only go until the character before the last. Cool. So see here, there are no errors. So let's try to run this. Oh, I'm sorry. before we run it, we have to call it on the top. So I'm gonna get this same, and I'm just gonna call no auxiliary structures, and I'm gonna run it here again, and you can see 2 falses. If we go back to a different string that has no repeated characters, for example, so we're gonna just replacing testing with vimgo again. So you can set this, and you can see here that we have true now. So it's a very basic and simple problem, but it brings up a few concepts here. So how do you represent a string in the system, and what you're gonna, which characters are gonna be using here? So can you use space? Can you afford the space to avoid having more loops and making your code slower? Or do you have constraints on space? So if we take a quick look, and maybe we could discuss these things later on in a different video, but our first solution here, it takes a fixed amount of space. In this case, the upper bound is going to be the size of the alphabet. So it's going to have 256. It's going to be always using these 256 characters, even if you have them or not. These are going to be allocated. But on the other side, you only have 1 for loop. It means that the maximum number of operations you're going to have here is the size of your string. It's bound by that, which makes this a linear algorithm, which makes it, well, relatively fast. Our second solution, it doesn't use any space per se. You're not creating, I mean, of course, if you're going to look at this strictly, you are going to be allocating index char1 and char2. But if you consider that you're not actually allocating any specific variables for this, again, you're going to have linear usage of space, but it's going to be a lot less than our first solution. But you're going to have now 2 for loops, and this is going to be now a polynomial solution. It's going to be, as we have 2 for loops on the size of the string, we could say that this is in O notation. We could talk about this in a different video, but in O notation, this is going to be ON2, which means that this solution is slower than our first solution. But now I have some homework for you. Trick question here. Do you think you can find another solution that doesn't use extra space like our first one, that can be faster than ON2? If you know the solution, if you think you know what I'm talking about, leave your answer in the comments. Looking forward to it. Thank you for watching this video, and I see you next time. Bye.